Salam everyone, welcome to another episode of Physics with Noshir Alim, and we are continuing our lecture from where we left last time. So, talking of potential divider circuits now. Now, with potential divider circuits, the first thing is you should know that potential divider, the word means series circuits, okay? Potential is V, and you know V splits in series circuits. So therefore, potential divider circuits are essentially series circuits. To give you an example, let's make a simple series circuit with a cell and two resistors connected like this. And let's call this as R1, let's call this as R2, and let's call this voltage as V input. All right. V input keh do, EMF keh do, anything you want to call it, just know that this is the input. And obviously when you will connect them in series, there will be a current in the circuit, right? Now, the first step is to use V is equals to IR, and instead of V, you put E or V input. So let's use V input. So when you put V input in that equation, I told you that whenever you are using the source, then you have to use I total R total. जब भी source voltage use करोगे तो I total R total करना है. Now Vn is equals to I total into what is R total? R total, because they're in series, it'll be R1 plus R2. That means that I total would be Vin divided by R1 plus R2. Now, this is the current that is going around my circuit over here. In my circuit, that current is represented by I. So I or I total both mean the same thing right now. What did I have to do? I actually wanted to prove that there is a voltage over here, V2, and that voltage can be found out in terms of R1, R2. So I'll again write V is equals to IR. Now, V की जगह मैं V2 लिखता हूँ. So the first question you will say that V2 के सामने resistor कौन सा लगा हुआ है? R2. So V2 जब लिखा हुआ है तो V2 में जो resistance आएगी, that will be R2, and the current will be this one because it's the same current that's going in, and this current is this what we found over here. So V2 is equals to I into R2. So V2 is equals to, now I की जगह आप expression डाल देंगे Vn divided by R1 plus R2 into R2. And therefore V2 is equals to R2 divided by R1 plus R2 into Vn. This is the expression that we wanted to find. We wanted to find the voltage V2 in terms of R2, R1 and R2. This expression has come as a proof in one of the papers, so you must be very careful in learning this. A lot of people make the mistake of not learning how to derive this, and they end up losing those marks. Don't lose those marks. This equation is very important because it's telling you one thing, that the voltage V2 is proportional to R2. This voltage V2 is proportional to R2. Now, you must understand, I'll give you an example. कि फॉर एग्जाम्पल यहाँ पर आपने 10 वोल्ट की बैटरी लगाई, ठीक है. अगर आपने 10 वोल्ट की बैटरी लगाई है और R1 के क्रॉस 3 वोल्ट्स ड्रॉप हो गया, तो R2 के क्रॉस कितना वोल्टेज ड्रॉप होगा? 7 volts. That is why it's called a potential divider, because this 10 volt is dividing now between 3 and 7. 3 plus 7 करें 10 आ जाएगा. कहना ये चाह रहे हैं that this 7 volt is dependent on R2. Just as an example, if you increase the value of R2, this 7 volt value will go up. For example, if you increase the value of R2 की value को हम increase करते हैं. If you increase it, then this value from 7 volts will go to 8 volts. But if this goes to 8 volts, then this 3 volt will no longer remain. Then this will become 2. Why? Because remember that you are applying the law of conservation of energy. And when energy is conserved, then law of conservation of energy कहता है that energy is always converted from one form to another form. So that means the energy that you've supplied is 10. The energy consumed will have to be 10, cannot exceed 10. So if this is 8, then this will be 2. So therefore, I can safely say that E is equals to V1 plus V2. So you can clearly see that there is a potential divider. The potential has divided between the two. And therefore, we say that in a series circuit, the potential will always divide. So yaad rakhna, potential divider is a series circuit. That's the first thing that I wanted to tell you. Now, the second thing, let's talk of another example. As another example, let's discuss, you have, let's say, this resistor over here, R1, and you have another resistor over here, and this resistor is labeled RT because this is a thermistor, and you have connected them to a voltage Vn. So यहाँ battery लगी हुई है Vn की जगह. And the question is, you have to find out what is the voltage across the thermistor. Now, because you had derived the expression, I will write down the expression for you. The expression was V given is equals to R given over R total into V input. Now remember that V given and R given are the resistor and voltage that you have to use in the numerator. In my example, R given is going to be RT and V given is going to be VT. R given or V given वो होते हैं voltage series में जो आपने निकालना होता है. I just have a name for it. You can use any other name. So whichever voltage you want to find, वो यहाँ पे डालें. उस voltage के सामने जो resistance है वो RG में डाल दें. So VG RG. And that is divided by the total resistance, which is R1 plus RT in this case, and V input is V input. So this equation, the general equation, you must remember. This is the equation that you derived earlier as well. If I apply this equation to this scenario, I would get VT is equals to RT divided by RT plus R1 into Vn. That is the application in this part. Now, they can ask you a question that because it's a thermistor, so a thermistor is temperature dependent, right? So you could have two conditions. You could have warm conditions or you could have cold conditions. Now, if you have warm conditions, that means that the resistance of the thermistor will be very low. If the resistance of the thermistor is very low, please try to understand that RT and VT are directly related. They have a direct relationship. So that means VT would go down. And by law of conservation of energy, please yaad rakhna, Vn constant hai, wo to kahin nahi ja raha. If VT goes down, then the voltage across R1 will go up, just the way I explained it earlier. So if RT decreases, VT will decrease. On cold conditions, the resistance of the thermistor will increase. And if the resistance of the thermistor increases, then the voltage across the thermistor will also increase. And if the voltage across the thermistor increases, तो obviously होगा ये R1 के across जो voltage है वो decrease हो जाएगा. I hope you are with me so far. This example that I've done with you, this whole example, is how you can use a potential divider with a sensor. Now the sensor could change. Instead of a thermistor, they could use an LDR. LDR में यहाँ पे bright or dark conditions आ जाएंगी, but analysis वही रहेगा as long as you remember that in bright conditions the resistance is low and in dark conditions the resistance is high. Everything else will remain the same. Right, next thing. Now when you're talking of potential divider circuits, the next thing that I want to talk to you about is a circuit in which you have a metallic strip, all right, and over here in front of that strip you have a resistor, okay, and that resistor is connected to a jockey, and across the resistor you have a voltmeter. Very important concept. This is if you want to get a variable potential difference. How can you use a potential divider to get a variable potential difference? How can you get a variable reading? How can this V change constantly? So for that you'll have to use this sort of a circuit. Now in this circuit, the first thing is that you need to identify that this is a metallic strip, okay? The metallic strip has its length L. So the metallic strip has a length L, and you know that the metallic strip has a resistance R. So let's say the resistance of this whole strip is R. Now, you know that R is proportional to length. So the whole length of this strip is representing a resistance R, resistance proportional to length. Remember with jockeys, whenever you get this sort of a question, the first thing is you identify the fixed end. Fixed end वो होता है जहाँ पर आपका जो resistor लगा होता है उसका एक permanent connection होता है. Fixed end is this end where your resistor is permanently connected. So the first step is identify the fixed end. This is your fixed end. Once you've identified the fixed end, you'll know the importance of it. Once you've identified the fixed end, all you have to do is you need to understand that jitna jockey दूर जाएगा उतनी length बढ़ेगी fixed end और jockey के बीच में. जितना jockey नीचे आएगा उतनी length कम हो जाएगी jockey और fixed end के बीच में. Remember, fixed end से length देखनी है, दूसरे end से length नहीं देखनी. So let's say jockey जहाँ पे अभी connected है, if you stay over here, then this length L1 is what matters, not the length L2. Remember this. L2 does not matter. L1 is the length which matters if you want to find out the voltmeter reading. Are you with me? So the whole length L, and this is the fixed end. So this length L1 is what will matter. L2 will not matter. Now some of you might say कि जी length यहाँ से क्यों नहीं ली from the edge. देखो, the strip is starting from here. The strip's length is what matters. So strip के start से शुरू करना है और वहाँ से length L1 और यहाँ से लेकर यहाँ तक length L2. अब if this jockey moves up, obviously L1 will increase, L2 will decrease, and if this jockey comes to this point, L1 will be maximum. Remember that you have to take it from the fixed end. If, God forbid, they move the fixed end over here, यहाँ पे fixed end बना देते हैं. If they move the fixed end over here, then not a problem, because now length L2 will matter, not L1. Remember that you have to take the length from the fixed end बार बार बोल रहा हूँ. Now, if I tell you, as an example, I say that the resistance of the wire is 30 ohms, all right? And the length L of this wire is 1 meter. If I ask you that what is the resistance of this part, itne se part ki resistance kitni hai? Because this is the part which is mattering to this voltmeter, because voltmeter ke samne ye wala hissa aa raha hai. This part does not matter. So if I ask you what is the resistance of only this part of wire, you'll use proportions because you know that the resistance is proportional to length. So if 1 meter represents 30 ohms, तो L1 कितना represent करेगा? Let's take an example. Let's say L1 is 0.2 meters. Okay. That means that the resistance of the metal in that part would be 0.2 into 30, isn't it? What is 0.2 into 30? 0.2 into 30 would be 6 ohms. So the resistance of the part which is right in front of the voltmeter is 6 ohms. Now you can automatically tell that the resistance of the remaining part will be 24 ohms. Why? Because if the entire resistance of this metal strip is 30, this is going to be 24 and this is going to be 6. But remember, to get the voltmeter reading, it's the 6 which matters, not the 24 ohms. The 24 ohms would have mattered if the fixed end was not here. If the fixed end was there, then obviously then the 24 ohm would have mattered. Now you know कि fixed end से देखना है. अगर कोई गलती करेगा, obviously answer आ जाएगा, but answer would make no sense. Now, you must understand again that I can simplify this diagram, and I can simplify this diagram and make it like this. So my cell, let's assume that the cell has a voltage of 10 volts. Okay. Remember, जिस point पे jockey connect होता है, so the jockey is connected over here. जिस point पे jockey connect होता है, उस point पे वो metal strip दो हिस्सों में टूट जाती है. So वो दो हिस्सों की दो अलग resistances बन जाएंगी. Now, the lower resistance would be 6 ohms, as you said, and the upper resistance would be 24 ohms, as you said. And 6 ohm के सामने आपका दूसरा resistor आ गया, and उसके सामने ये voltmeter आ गया. The question was to find out what the voltmeter reading is. So let's assume just for argument's sake, let's assume iski bhi resistance 60. So that means this is also 6. You have to find the voltmeter reading. So how do you find the voltmeter reading? Very simple. First, you solve these two in parallel, make them 1. So do 6 into 6 divided by 6 plus 6. That is going to be 3 ohms. All right. So when you will simplify the circuit, you will get the 10 volt battery and then the 24 ohm resistor. And now you have a 3 ohm resistor, which represents this combination. So this combination over here is represented by the 3 ohms. And in front of the 3 ohms, you have your voltmeter V. So you have to find the voltmeter reading. Just apply the same potential divider formula. It's the same question that you saw earlier. So the general formula was, I'll write it down again, V given is equals to R given divided by R total into V input. Let's put the values in. So V given is V, जो निकालना है. V given के सामने R given is 3 divided by the total is 27, which is 24 plus 3 into 10. Whatever answer you get is going to be your final answer. I hope that this concept is clear to you. Now, once you've found out this value of the voltmeter, you must understand that this voltmeter reading will change if you decide to move this jockey. So if the jockey is here and you decide, no, I want the jockey to move up, now you should be able to answer this question. If the jockey moves up, length L1 बढ़ेगी या कम होगी? Obviously बढ़ेगी. और अगर length L1 बढ़ेगी, so answer my question. If length L1 increases, what will happen to the voltmeter reading? It will increase. If the voltmeter reading you want to increase the length L1. You want the voltmeter reading to decrease the length L1. That is why we call it a variable potential divider, because you can vary this voltage by moving the jockey up or down. Remember, the fixed end is what plays the role, and then all of this calculation that I've done is eventually what's going to get you to the right answer. Clear? Brilliant stuff. So that's it for this lecture. Now, one of my finest students, came up with this hilarious version of my introduction, and he showed it to me in class on Saturday. At first, मेरा honestly हंस के बुरा हाल हो गया था उसको देख के. I will leave you to be the better judge of it. Not saying that you should do it very often, but I just thought I should share his talent. I hope कि उसने जितनी मेहनत से ये इंट्रोडक्शन मेरा अमेंड किया था, उतनी ही मेहनत से उसने वो लेक्चर पढ़ा भी होगा. And I wish you best of luck, Atik. And this is dedicated to you. Here you go, guys. Enjoy his intro. Take care.